Install Tripwire, U for upgrade, and Tripwire, and it installs it. Okay, so it installs some configuration files as well. So the only thing, what you need to do is first install Tripwire, however you do it, either from a source package or an RPM or a deb file if you're running Debian. And then let's go to the etc Tripwire directory, where we'll see that it gives us two starting files, a configuration file here, and a policy file here. Let's look at the simplest one first, the configuration file. And that just tells us where the root, where Tripwire binary will be located, which is in user sbin, where a policy file is located. Realize you can put these anywhere you want. You just have to indicate in the configuration file, you have to update this to indicate where the actual files have been placed, but I'm keeping them in a default location. Here's a database file that's going to be in the var live tripwire directory, and it's the name of the actual database is going to be prepended with a host name, and then with a .twd as the extension. There's a report file that's created whenever you run a check of Tripwire, and a check, of course, is just going to take the hashes that are located in the database and compare those against the current hashes of the files that you're concerned with. That's going to be located in the var library tripwire report directory, and the name of the actual report is going to be hostname -date and .twr as the extension. Because we want to make sure that no one can change the configuration and policy files, we have to have a cryptographic key which is used, and we have two that are created. One's called the site key, and that's going to be located in etc Tripwire site key, and this one is going to be called local, which will be located also in etc Tripwire, but it will have the host name and then a -local.key is the extension. Here's the editor that we can use, and we can use anything we want for the policy file and configuration file. Here we have a couple of different attributes right here. The loose directory checking is used because sometimes the actual directory that a file is located in isn't exactly the same depending upon the Linux distribution. So if we were concerned about that, we would change that to true. The email report level, we can indicate how detailed the reports are by changing this to a higher or a lower value. The mail method, you can set this system up so that when you run Tripwire check, let's say as a cron job, that it actually uses sendmail to send you the report. And you can also send you information directly to syslog if you like. Here it's got faults in here. Let's change that to true, just for, oops. Save that. And the mail program to use is sendmail, which is the SMTP program. So we're really using all the defaults here, except we've changed the syslog reporting to true because we want something to show up in syslog. Now let's go to the POL text. Okay, notice that it says right here, this is an example Tripwire policy input file. It's intended as a starting point to create your own custom Tripwire policy, because this is not going to work exactly for every different distribution that you might use, and also it may not match up with your actual security policy that you've created, and because your Tripwire policy should always follow your security policy in terms of what files on the hard drive should not be changed. So you want to create your security policy first, followed by your Tripwire policy. And then we can move down here. Here we have some global variable definitions. So this mimics what we saw in the configuration file. We see the host name is the host name of this computer. And then here's some important information in here. This indicates variables and what they signify. So the SCC_crit is for critical files that cannot change. The SUID files are for the SURD or SGID flags that are set. We've talked about that in the previous class and why those are important. binary files that should not change, and so on. Down here, notice here is that because not every file will be as critical as some other files, so you can set the significance to low, medium, or high, or create your own values. And then we can set those to a different number, indicating the higher the number, the greater the criticality of the file. So you see the 100 is for the significance high. For medium, it's 2/3 of 100, and low is 1/3 of 100. We can do our math. Then we have our rule names. So the first one is for the Tripwire binaries. We set the severity to high, because if somebody comes in and changes the Tripwire binaries, the reason they did that could be a rootkit that changes the Tripwire binary so it overlooks files that have been uploaded by an attacker. Also, we don't want somebody to come in and change the Tripwire data files either. And here we go. We've got our policy files. Notice it says tw.pol, tw.cfg. Let's go quickly out here and notice it. Those are just text files. Those aren't. Those are not the actual encrypted files that we have. And so what we'll do soon is we'll actually go ahead and create the encryption keys, and then that will be used to encrypt the policy file and the configuration file. We also don't want the local key or the site create encryption files to be changed either. That's very important, because if there is a change in any of these files, it could be that somebody's actually broken in and tried to change Tripwire so that it doesn't indicate that the file has been changed. Here for invariant directories, what that means is that some of the files are probably going to be changing in the home and Etsy, because home will be your data files and Etsy will be your configuration files for your system. What we don't want changed here is the ownership of the home and Etsy directory. So notice that it says recurse equals 0. That means that just check the ownership of the home and Etsy directories, but do not check the files underneath. We don't want the file and disk administration programs to change, such as fscheck. Let's see some down here. Notice that these things that are in blue have been commented out. That's because they're probably not relevant to this system. It's a different Linux system, or maybe this original policy file might have been created for an older Linux system. The mount command, change mod, change group command, make directory command, and so on, the remove command, the touch command. We don't want anybody touching the kernel administration program, since that's the heart of the operating system. We don't want anybody to, for example, go in and change one of the programs, for example, like ensmod, which allows you to insert a module. And let me see. So those should not be changed. And we don't want anybody changing the networking programs on the disk. And this is pretty much system administration programs. We don't want anybody changing. That makes sense. Notice that all of these are saying severity high. It's probably up to you to go in and determine what files would be at a medium and a low severity, and then you would create your own rules based on the same syntax as you see here. System information programs, small related programs, operating system utilities you don't want somebody changing. For example, let's say somebody changed the kill program so that it doesn't just kill the a single process, but maybe kills all the processes and halts your system. Or it could be that somebody created a program that's named kill that actually goes ahead and deletes certain key files on your hard drive. And of course, here's the PS command, which shows running processes. This is a command that's typically changed by, as well as netstat, by Trojan programs, rootkits, and so on. So what you really need to be careful, though, is you need to look at any of these files, and if any of these files in here you set up to change on a regular basis somehow, I don't know that you would, then you're going to get a very large report, which takes quite a bit of time to go through. And so you want to keep this to a minimum, just checking the files that you feel are critical to be checked. Okay. So you know what we're going to do is we're going to, let's clear the screen, and now we're going to set up our key files, our encryption keys. So what we need to do now is we need to protect that key file by indicating a passphrase. So let's make that a good passphrase. We need to verify it. So it's setting up one for the entire site. It creates a key. Now we want one for the local key file. Now we need to sign the configuration file. You have to enter our passphrase to do that. And we need to sign our policy file with the keys that were created. Now let's take a look at the files that were created in here. Notice that we've got our local key for Fedora 6.ucf.edu. We have the site key, encryption keys, and then these have been the TWCFG text and TWPOL text files have been encrypted and signed with each of these keys. We want to be careful with these keys because if somebody's able to get the key and find out the password, they're able to go back and check these and change your configuration file and your policy file, and you may never know that. Now what we need to do is we need to initialize the Tripwire database. So in order to do that, we type tripwire-init. What this is going to do is first it's going to go through and unlock the policy file and configuration file, read those, and then based upon that, it's going to create hashes of all the files and directories indicated within those files, and it's going to write that out to a database, which is then encrypted. So it asks us for our passphrase, which now we do, which is going to unlock those keys. Notice here it's saying warning, file system error, no file found. That's because our policy file had these files indicating that when they don't exist on this version of Linux that we're running. So what we want to do is go back in and take out those files from the policy file. So when we do that again, let's make sure that let's just do a couple of those. Proc, PCI, proc, SCSI, dev, kmem. So we'll change our policy file. Now I'm going to pause this for a second because this is going to take quite a while to go through. Take quite a while to go through here and do all this. So all it's going to do is just be boring and eat up video. Okay, so Tripwire initialization is finished. It's received the message that wrote the database file Fedora 6.ucf.edu.twd. The database was successfully generated. And now let's do a couple of things. Let's go back in and let's change that policy file. twpol.txt. And here we go. We want to take that out because that doesn't exist. And PCI there. I didn't take out all of them. I just took out some of them that were indicated they weren't found. Now let's go change one of the files. Oops, let's go back in here and see one of the files. Let's see. Here's the kill all. Let's change that kill all command. Kill all. Wait a second. rpc.logd. Let's change that file. Okay, so we're going to move the rpc.logd. Let's pretend that we've broken in and we're changing some things around to rpc.logd.foo. There we go. And then let's copy rpc.statd to rpc.logd. Okay, if we run a hash on those, we're going to know that. Notice that rpc logd and statd are the same. That's because we could just copy this one to that. And so Tripwire should find that difference and indicate as such in our report. Okay? So let's go back here. Let's clear the screen. Now let's run Tripwire again. And see what happens. Oh, you know what we didn't do? We didn't update that policy file, so we need to do that. Hold on a second. It's been a while since I've done this. Let's do that. Okay, to do that, we need to type twadmin, and that's one of the files that's used to administer Tripwire. To find out more about it, type man twadmin. And we're going to type twadmin, create profile, oops. I'm going to create profile, create policy file. There we go. So we're going to create a new policy file. We're using the site key right here. Just make sure that, oops, knows where this is located. Let's see, Tripwire. Now it's asking for our passphrase to open that site key. And now we got a new Tripwire policy file that's been signed with our site key. There we go. Now we can type Tripwire check. And let's see what happens. So this is good because what it shows us is that the current policy file was not the same one used to create the database. So if we need to go back and change that, recall that we took out some of the files within the policy file. So we need to go back and type in, oops, Tripwire init, and this will go back and reinitialize the database. Which is kind of screwing up everything because I've already gone ahead and changed those files within the SBIN directory RPC. We'll go back and change those. In fact, we'll just go back to change those what they should have been originally, and then Tripwire will catch that. Notice that we're not getting those errors that we saw before for proc PCI and proc SCSI or dev kmem. So we would want to go back and change the policy file to take out that file, which doesn't exist in that file. And let me pause this for a minute. Okay, it finished, and notice that we still have a lot of files not found in here. But what we don't have are the ones that we took out of the policy file. Okay, now what we need to do is we need to go back to SBIN we need to delete rm_rpc.lock d, and we move rpc.lock d foo back to rpc lock d there. Now, because the Tripwire went on ahead and calculated the MD5 hashes of these files and stored them in the encrypted database, now it's going to find that these two files have changed. Hopefully, let's go back and run check. And I'll pause for a few minutes. Okay, we're back. Notice that some of the files that we included in the policy file, it's still not finding. Of course, what we don't see in here is proc PCI, proc SCSI, and dev kmem. Here we go, and it wrote the report file, var library tripwire report, Fedora 6, and then today's date, TWR extension, and here's our integrity report, which was put out to the screen. Report generated by root, the time, database last updated on never. And that's wrong because it was updated. Okay, the host name, host IP address, host ID, policy used, configuration file used, command line used. Let's see what it shows. The user binaries. There's one that was removed and one that was modified. And of course, if one is removed, that's been modified, and that's why it shows up in those two columns. System administration programs, one has been modified. Total violations, 3 out of 28,739 scanned. And that was the one that was removed. And it's saying that was the one that was modified. You modified the access time of that directory. And RPC lock D has been modified as well. So it went in and it found those files that have changed. Of course, that was output to the screen. What we really want to do is have that mailed to us. Let's see if it showed up in our mail. I really haven't set that up so that it hasn't shown up yet because I didn't set up the mail program to do what it should do. But what we can do is we can use the twprint command, -mr, which says to decode a Tripwire report. And then we need to give it a TWR file that indicates that the file to decode. And we want to decode the last one, which is 1.4. And this is essentially the same thing that we got from the output screen. Just notice that it correctly indicated the files that were removed and modified. Remember now that when you create your policy file, that this can be huge. I used to run this every day and have this mailed to me. And it got to the point where it was just so overwhelming that I stopped looking at it. So you need to be judicious in what the files that you include in the policy file. You just don't want to include things willy-nilly just to see what's changing on your hard drive, because this report will be pages and pages and pages, and after a while it'll just be so tired looking at it you will fail to look at it. So make sure that you're careful about what you include in that policy file. And so now hopefully you've seen how to install and run and configure Tripwire. So you should do this yourself if you can. And if you're in a system administration position, if you're running something like Linux or some version of Unix and even Windows, you can download the freely available Tripwire open source program. Recall that there's also a Tripwire that is commercial off the shelf, which is very expensive, but you can still use this one to your advantage.